So let's look at an example here. Let's say we want to know if this series is going to converge. And we're going to use the integral test to do that. To figure out whether this converges or not, the first thing we want to do with the integral test is we want to represent this sum right here as a function. Or, I'm sorry, this general term here as a function. So the function that we're going to use, call it f of x, is going to be what? 1 over x square root of x, which is the same thing as what? Anybody know if we write that in exponential form? X to the, how about negative 3 halves? So if we were to find the area under this curve, under the curve x to the negative 3 halves, from 1 to infinity, or if it doesn't work from 1, we could actually start at 10, or we could start at 100, or we could start at 1 billion. It doesn't really matter where we start. But if we can find the area and show that that area converges, then we know that this series converges. If we find the sum and we find that that sum diverges, then it turns out that this series is also going to diverge. So we're going to set up an integral here. We're going to take the integral from, I'm going to start at 1. And there's no reason not to start at 1 because it's going to be defined, it's going to be continuous. It's actually going to be a decreasing function. We'll just take that for granted right now. I'm not going to take the time to show that it's decreasing. So I'm going to take the integral of x to the negative 3 halves with respect to x from 1 to infinity. And let's see what happens. All right, so since it's an improper integral, the first thing I need to do is what? Set it up as a limit, yes. So we'll take the limit as what variable you guys want to use? A? So the limit as a approaches infinity of, x would have been a poor choice there. The integral from 1 to a of x to the negative 3 halves with respect to x. And we can evaluate this definite integral right here fairly easily. I'll just do that off to the side here. 1 to a of x to the negative 3 halves dx is going to be, what's the antiderivative of x to the negative 3 halves? It's going to be x to the negative 1 half divided by negative 1 half, so it's going to be negative 2x to the negative 1 half. And we need to evaluate this from 1 to a. So what do we get when we put a in here? Negative 2 over square root of a minus negative 2, which is the same thing as plus 2. So going back up here, we get the limit as a approaches infinity of this quantity right here, that expression. So it's going to be negative 2 over the square root of a plus 2. And so as a approaches infinity here, what's going to happen to this term? Well, okay, so the square root of a is going to be infinite, so then this term is going to be 0. So this limit is equal to 2. Now, it actually doesn't matter what it equals. The only thing that matters is what? Whether it converges or diverges. So since this integral, this improper integral, converges to a constant, to a finite number, then what do we know about this? It converges. So since the integral converges, then the series converges. Why does the series converge? By the integral test. And the work for the integral test we did up here, so you don't have to repeat the work or anything there in your explanation. All right, so since the integral converges, the series also converges by the integral test.